Welcome everyone. In this video we are going to learn about Newton-Raphson method. So I'll just go through the key points. So it is a iterative numerical technique for finding the roots of a real valued function. That is, by repetitive process we are going to find out the roots of the function. It has fast convergence properties. It means that is we are going to obtain the solutions quickly. Then what are the advantages? So the all the working of the successful working of the Newton-Raphson method depends on the initial guess. So if the initial guess is close to the roots, then there will be fast convergence. Convergence means finding the solution, and it works well for smooth functions. Now what are the disadvantages? This process may fail if the derivative of the function is equal to 0. Okay, and as I have told, its performance depends on the initial guess. So if the initial guess is far from the roots, then it will perform in a poor way. So what are the steps of Newton-Raphson method? So first we will have to choose an initial guess for x naught. X is the root which we are trying to find. Then we are going to evaluate f of x, means we will put the value of x naught in the function f and we will get the value, and then the derivative of that function, by putting this value we will try to find out. Then compute the next approximation using the formula. Which formula? This is the Newton-Raphson formula. X of n plus 1, that is the next improved guess, is equal to x of n, the initial value that you have put, minus f of xn divided by derivative of xn. Okay, and then we will keep repeating the process. Till when? We will keep repeating the process till the value of the new improved root minus the old initial guess is, old value of x is smaller than a tolerance value. So we will choose a tolerance value. So if this difference between these two becomes, until this becomes less than the tolerance value, we will keep repeating this process. So this is about Newton-Raphson method algorithm. Now we will try to solve it with the help of one mathematical example. So this is let's take this as the example. Find the root of f of x equal to x square minus 4 using the Newton-Raphson method. So first we are going to, so f of x is this one. So we will first try to find out the derivative of f of x. So if we find the derivative, we get 2x. Now let's make some initial guess. Suppose we are making the initial guess of x equal to 3. Now we will simply put 3 in this f of x, in this formula. So what is this formula? As I have told, if we see the steps, this is the formula f of xn plus 1 equal to xn minus f of xn divided by f dash of xn. So we will put it in the formula. So for x, this is the initial guess 3 square minus 4, we are putting the value of 3 here into 2 into 3. So what is the value we get? 2.166. So this is the new value of x and the original value was 3. Now if we find the difference between 3, the old value, and the new value, the difference is pretty big. Suppose our tolerance value is 0.001, just assume. So if we see the difference, it is very big. So we are going to repeat this same process. Now for next process, what will be the value of x2? So this is our this will become the initial guess now. Then we will put it in the formula, and suppose we are getting 2.0064. So this is our new value. Again we will try to find the difference between the old value and the new value. Now again, if the difference is greater than the tolerance value, we will keep repeating the process. The moment the difference becomes less than the tolerance value, that particular value of x will become the root. Okay, now we will try to apply this particular algorithm, that is the Newton-Raphson method, using C++. So first we are going to include the header files. So obviously we will need IOStream. Okay, then after that we are going to use CMath. Okay, fine. Now we are going to now I will have to write down using namespace std. Okay, So after that, let us define the main function. Okay, we will do it step by step. So first let's define main. So inside it we are going to declare the variables. How many variables we need? We need x0, the initial guess, and then we need some tolerance value. Okay, and after that we need how many iterations we will be performing. So let us give it as max iter. Okay, now we are going to take the input, enter initial guess. So initial guess part will come inside this variable. We will put it here. Then next we will ask enter tolerance. Okay, so you can give any value you want. C in tolerance. Okay, TOL. And after that we are going to ask how many iterations you will give. Okay, enter maximum iterations, that is how many times you want to repeat the process. So you will give some value here, so max iter, that's it. Then after that we are going to call the function Newton-Raphson. We will call this function, and what we are going to pass here, we are going to pass x0, tol and max. So these are the values that we are going to pass, and then here we are going to write down return 0. Okay, now let's after this let us define the function. Okay, because we'll be needing, if we see the algorithm, we have f of x, right? So let us assume that f of x is equal to x square minus 4x minus 10. So obviously we need that function to return some value. So let us write it as double. So it will put some value of x here, right? So here what it is going to return? It is going to return x square, x into x minus 4 into x minus 10, because this is the function that we are assuming. So, and now similarly we need to define one more function to get the derivative of this one. Okay, so let us give it as fx. Okay, derivative. So it is also going to return some value. Okay, so what it is going to return? Fx. So what is the derivative of x square minus 4x minus 10? It is 2x minus 4, right? So we will just write down return 2 into x minus 4. Okay, so these are the two functions that we have defined. Now we will define this function Newton-Raphson. Okay, so we will just write down. So this is also going to return some double. No need to it is not going to return anything, so I'll just write down void then new Raphson, and here what we are going to take as argument double x naught comma double tol and then int, because the data type of maximum iteration is int. Okay, so inside it we are going to write down the Newton-Raphson method. Okay, so let's define the function Newton-Raphson. So for this we will be needing few variables. So first of all, let us give x, that is for the new approximation of the root, right? So initially it will have the original value, so we are giving it double x equal to x naught, and then how many times our loop will start. So initially our loop will start from iteration equal to 0. Okay, so how many times we will do the loop? While iter is less than, you can give less than equal to max, that is the maximum number of iterations we are going to do it. So each time we will run the iteration loop. After each iteration we will increment the value of iter. Okay, so this is the basic structure. Now we know that if the derivative of f of x is equal to 0, we cannot proceed with the algorithm, right? So we will have to give that condition first, then only after that only we are going to implement the process. So here we will check the derivative. So we are going to write if the derivative, that is f of x, right? So this is the derivative. If f of x is equal to 0, then what we are going to write? We are just going to write, one second, we are going to write cout method fails. So this is the condition already given in the algorithm, I have already told, and we are going to return, right? Otherwise we are going to proceed with our algorithm. So for that we need to find out the next value of x. So let us give it as double x next, or you can give it as xn equal to the old value of x, which is x. What is the formula? X minus f of x divided by the fx of x. So this is our formula, right? So this is the formula we will have to write. So after that we will have to find out whether this is less, the new value minus the old value is less than tolerance or not. Okay, so till this part it is clear. Okay, one more modifications we need to make. So here I have given the name as maxiter. Here I have given it as max. So I'll just make it maxiter. Okay, and then here I can give max. It doesn't matter because the value of maxiter will be copied to the variable max, right? Now after this, after reaching the maximum iterations also, if this value doesn't becomes less than the tolerance, so what we will write? We will simply write maximum iterations reached. Okay, maximum iterations reached. That's all we are going to write. Now let's see how it works. Don't forget to save the program. So go to execute, compile and run. So initial guess, what is the function we are using? X square minus 4x minus 10. So for that, suppose initial guess we are making as 3. Let us give the tolerance value as 0.0001. Okay, maximum iterations, let it be 50. So what is the root we are getting? 5.74. Okay, so this is how Newton-Raphson works. So you can change the values of these things to play with the